Biomass transfer is a fundamental process in ecosystems, describing how energy and organic material move from one trophic level to the next in a food chain. However, as biomass is transferred between trophic levels, a significant portion is lost, leading to a reduction in the amount of energy and material available to organisms at higher levels. Understanding how and why this biomass loss occurs is crucial for grasping the dynamics of ecosystems and the limitations on the number of trophic levels a food chain can support. Biomass loss between trophic levels occurs for several reasons, primarily due to the inefficiency of energy transfer in living organisms. When a herbivore consumes a plant, not all of the plant's biomass is converted into herbivore biomass. A large portion of the plant material may be indigestible, such as cellulose in plant cell walls, and passes through the herbivore's digestive system as waste. Additionally, much of the energy contained in the plant material is used by the herbivore for its metabolic processes, such as respiration, movement, growth, and reproduction. During respiration, for example, energy stored in organic molecules is released to power cellular functions, but most of this energy is ultimately lost as heat, which dissipates into the environment rather than being transferred to the next trophic level. As a result of these processes, only a fraction of the consumed biomass is converted into new tissue that can be eaten by the next trophic level. This leads to a decrease in biomass at each successive level in the food chain. For example, when a carnivore eats a herbivore, it may only gain about 10% of the biomass that the herbivore had, as the rest has already been used or lost. This inefficiency of biomass transfer is why food chains typically have no more than 4 or 5 trophic levels. Beyond that, there simply isn't enough energy remaining to support higher levels. The efficiency of biomass transfer between trophic levels can be calculated to quantify how much energy or biomass is passed from one level to the next. This is done using the formula on the screen. For instance, if the biomass of herbivores in an ecosystem is 500 kg per hectare and the biomass of carnivores that feed on these herbivores is 50 kg per hectare, the efficiency of biomass transfer from herbivores to carnivores would be as shown on the screen. This calculation shows that only 10% of the biomass consumed at one trophic level is converted into biomass at the next level, reflecting the significant losses that occur due to metabolic processes, waste, and energy dissipation. Understanding biomass transfer efficiency is vital for ecological studies and conservation efforts, as it helps to predict how changes in one part of an ecosystem can affect the entire food web. For example, if the efficiency of biomass transfer is particularly low in a given ecosystem, even a small reduction in producer biomass can have a profound impact on the higher trophic levels, potentially leading to population declines or extinctions. Additionally, these calculations can inform sustainable practices in agriculture, forestry, and fisheries by identifying the optimal ways to manage resources without depleting the biomass base that supports various trophic levels. In summary, biomass transfer between trophic levels is a process marked by significant energy and material losses due to metabolic needs, inefficiencies in digestion, and waste production. The efficiency of this transfer can be calculated to provide insights into the functioning and sustainability of ecosystems, revealing the limits on energy flow through food chains and the potential impacts of environmental changes.